Hello students, today's agenda is to check homework. We'll be relearning rational exponents and you'll be able to do 1.2. This is a review of converting between rational exponents and roots. And before we do that, I would like to give you a list of the first 15 perfect squares. So if you want to pause the video and write them down. And why are they called the perfect squares? Well, even though this is not a perfect square, it just means that a number multiplied times itself, it will give me a product, and those products are perfect squares because it's the same number being multiplied. So in here the example is 9 inches times 9 inches is 81 inches square inches. And so the first perfect squares is 1, 4 because 2 times 2 is 4, 9 because 3 times 3 is 9. So these are the perfect squares: the 1, the 4, the 9, the 16, 25, 36, 49, 64, 81, 100, and these are the numbers that multiply times itself twice gives me that number. Okay, the next 5 is 121, which is 11 times 11, 144, which is 12 times 12, 169, which is 13 times 13, 196, which is 14 times 14. Notice how they have the 1 and then they switch 6, 9, and then 9, 6. Okay, and then 15 times 15 is 225. And you can learn more because that makes your life easier now that we're starting this section of quadratic equations. But yeah, these are going to be very helpful to learn. Okay, so before we start, we're going to do an analysis of something that we already did, but I'm going to give you more examples so that we did it in Math 1. Now we're going to do it in Math 2. And so it's just a relationship of 25. Okay, we're going to write 25 in different ways. And so we know already that 5 squared is 25 because 5 times 5 is 25. We also know that 25 to the first power is 25. Okay. But what if I put square root of 25? Well, that will together, or that part alone, gives me 5. So to make it 25, I would have to square it. Right? And from previous lessons, we know that when we have, let me just put any base. This is not part of that, but just a review of what we saw in the last lesson actually. 3 to the second power, all raised to the fourth power. Well, we remember that we keep the base and we multiply the exponents, right? So 2 times 4 is 8. Just a reminder of what we do with exponents or powers raised to another power. Okay, having that in mind, if I put 25, and then I'm gonna need a number in here, right? An exponent. But then I put a 2 in here. What would this have to be to make it 25? Well, we know that 25 to the first power will give me 25, right? 25 to the first power is 25. So since I already have the same base, 2 multiplied times what gives me 1. Remember, we have to multiply the exponent inside and the exponent outside to make it for the powers of powers. Well, this is going to have to be 1/2 because 1/2 times 2, we put it over 1, we multiply straight, and 1 times 2 is 2. 2 times 1 is 2, and 2 divided by 2 is 1. Okay, so I needed that to be 1/2 so that the whole product becomes 1. And that way 25 to the 1 is 25. Again, I don't know if you remember this from Math 1, but what is important in here is this part right here. There is a 2 in here, there is a 2 in here, but that means that if both of these inside of the parentheses are raised to the second power, both are raised to the same second power, that means that this is 5 and that this is 5, just alone without that power. So we can say that 25 to the 1/2 is exactly the same as the square root of 25. Okay, and you might want to rewind the video so that you can see the relationships between all of this. This helped me figure out that I needed to put a 1/2 in there. This helped me figure out that 5 to the second power is 25, so this is 5 to the second power is 25. So once I figure out this to become 1, that means that this is also 5. Okay, so indirectly we found that this is true, that 25 to the 1/2 is the same as square root of 25. And so let's do now more examples of specifically just the relationship of rational exponents and the square roots. Okay, so because of what we just saw, we can then say that the square root of x is the same thing as, we have the same base. Notice how we have the same base, right? The 25. But then there is an exponent in here and an index 2 in here. So this one goes here and the 2 goes here. So if it doesn't have an exponent, that means that the exponent is 1. If there is no index, that means that the index is 2. So this is converting from a root to an exponent. So convert from a root to rational exponent. And since it's review, I'm going to go a little faster so that you can see the relationship. So now we have a cubic root of x. Again, this is going to stay the same. If there is no exponent, there is a chiquitito. It's going to be 1 over 3. For the next one, we don't have an index, but we have an exponent, so it's going to be keep the same base. The exponent becomes the numerator. The index becomes the denominator. Since there is no index, it's a 2. Okay? We never use the 1 as exponent and the 2 as index. We never use that. What about... Let me show you also. The exponent can be out here or it might be here. So it doesn't matter, it's the same. You might have it outside or inside, it's still the same. Okay, so we keep the same base. The exponent becomes the numerator. The index, which is not there, but we know it's a 2, becomes the denominator. And so that can be simplified. So it's going to be just x. X to the 2 divided by 2 becomes 1, but we don't put the 1. It's a chiquitito. We don't need it in there. Okay, for the next one, we have index 5, and we have x to the 3rd. We can have it here or here, it doesn't matter. Again, keep the base. The exponent becomes the numerator. The index becomes the denominator, and that cannot be simplified, so that's it. Now, that was to convert from a root to a rational exponent. Now, let's convert to a root. And if you need time, if you need more time, just remember to go ahead and pause the video, rewind it. Okay, so for the root, we put the same base. The numerator becomes the exponent. The denominator becomes the index. Okay? Keep the same base. The numerator is the exponent. We don't need the chiquitito. Okay, the tiny one, we don't need it. And then the index 2, we don't write it either. So that's it. Same, keep the space. Exponent 1, we don't put it, but the index 3, we do need to put it in there. I'm going a little fast, but if you need to review more, you can always go to 8.5 from Math 1C. Or you can come in and ask me for access to that video, okay? The next one is x to the 5/3 or 5/3. And so, same base. The numerator becomes the exponent. The denominator becomes the index. Sometimes they're going to ask you to evaluate. Okay? And so you can either go directly from rational exponents. For me, it's a little easier to go from the roots. So it's up to you. So if I have, oh no, that's not what they're giving me. I'm sorry. So they're giving me a to the 2/3. It just means that I'm looking for a number that multiply times itself 3 times is 8. And then that answer is going to be raised to the second power. If you can do that, that's fine. Some people already know that 2 times 2 times 2 is 8. So that will give me the answer for this section. And then raised to the second power will be 4 because 2 times 2. But I personally need to see the root. So I convert it to a root first. And so I put same base. The numerator becomes the exponent. Again, it can be inside and outside. It doesn't matter. And the denominator becomes the index. Now, I work with this first, and then I'm going to send that to the answer. And so, in here is going to be prime factorization. So 2 times 4, 2 times 2. Then it says, cage 3 in each group. Enclose 3 in each group. And just send the captain. So this don't go in there. It's only the captain. And this exponent goes over here. Okay, this is the 2. So 2 to the second power means 2 multiplied times itself twice, so it's going to be 4. So evaluate is similar to simplify, answer, evaluate, solve, okay? It just means take it to the, like all the way to the last answer you can get. Okay, the next one is 25 to the 3/2. what that means in a root is keep the base. This becomes the exponent. I think I left too little space. And this becomes the index. You don't need to write it. So I'm going to do prime factorization, which is 5 times 5. And then in here, this number, which is, we already know it's a 2, tells me how many in each group. So it's 2 per group. I only send the captain. And don't forget to send that, some people said the little hat, el gorrito. Okay, so 5 times 5 times 5, which is 125. Because 5 times 5 is 25. And 25 times 5 is like saying 5 quarters is 125. The next one is 100 to the power of 3/2. Again, if you want to do it directly from here, it says one number multiplied times itself 2 times equals 100. Oh, that's 10. 10 to the 3rd power. Oh, that's 1,000. Because 10 times 10 is 100 times 10 is 1,000. Okay, so if you need to see it with the root, is the same base. The exponent goes here. The index is 2, so we don't put it. And then in here, we're going to get 2 times 50, 2 times 25. And yes, you can go to 10 times 10 immediately if you want to. 5 times 5. I just want to demonstrate how you do it with when you have more numbers. Since I don't have an index in here, it means that the groups are going to be 2. So I'm going to enclose 2 in each group. 2 in each group. And I'm going to send the captain from each group. So it's 2 times 5. And that gives me 2 times 5 is 10. And that's where I send this exponent. Don't forget it. It just means 10 times 10 times 10. Careful, don't say, I don't know, some people say 30. 10 times 10 is 100. Times 10 is 1,000. So that's the answer. Okay, 32 to the 4/5. One number multiplied times itself 5 times is 32. Well, it looks like 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So if you work with this over and over and over, they become easier and easier and easier. So the 32 stays the same. The 4 becomes the exponent, and the 5 becomes the index. It just means one number multiplied times itself 5 times gives me 34. And then that answer raise it to the 4th power. Did I say 34? I'm sorry. Gives me 32. Okay, so it's going to be 2 times 16, 2 times 8, 2 times 4, 2 times 2. And it says enclose 5 in each team. So 5, 1, 2, 3, 4, 5. Again, the reason for which we are not enclosing number 4, number 8, number 16, number 32 is because they continue to be factored. And the 2 are not being factored anymore. Okay, they're all the way to the end. And only send the captain. So it's going to be 2. Then this goes here, and 2 times 2 is 4, times 2 is 8, times 2 is 16. Okay, it means 2 times 2 times 2 times 2, which is 16. Okay, one more. Maybe you want to try it on your own. Pause the video and try it to see how you do. Okay, so this is the time to pause it if you would like to try it. Keep the same base. The numerator becomes the exponent. The denominator becomes the index. And so some people say, oh, can I just do 4 times 8? That's fine. You can then go to each one. So 2 times 2, 2 times 4, and 2 times 2. It says make groups of 5. So 1, 2, 3, 4, 5. But only send the captain. And don't forget the little heart. And so it just means 2 times 2 times 2 times 2 times 2 times 2, which is 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. So the answer is 64. Okay, now you can work on 1.2 and have fun.